All right. This video is going to present what's happening in 9.2, multiplying and dividing rational expressions. Remember in 9.1, we added and subtracted rational expressions, and we also had to keep in mind excluded values. We still need to worry about excluded values here, but let's take a look. So here's a problem. We're going to multiply these two rational expressions. There's no way I'm going to make you multiply this times this or the denominator. Instead, we're going to factor and simplify, right? Things that are in the numerator and the denominator, we're going to simplify those right out of there. So the key is factor, 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 factor. All right? So I'm going to start by looking at my trinomials here. And I believe those are the factors. I believe these are the factors. Now over here, I'm going to bring it 2x squared minus 6x minus 20. You might need to take it to the side and spend a little room trying to factor this thing. So notice what we have there. We do have, again, x minus 5x plus 2. So that can go up here. Right, let me rewrite now factored what I'm looking at. I have 3x squared over x minus 4, x plus 2, times, I have a 2, I have an x minus 5 and an x plus 2, over x minus 5 and an x plus 2. So let's see what we can simplify. We have x plus 2 in both of those. We have x minus 5 in both of those. And I think that's all I see that can be simplified. So now I will bring these together. I have 6x squared in the numerator over x minus 4, x plus 2. That is my answer for the multiplication. I do now need to make sure I take into account excluded values. I always go back to the original denominator before anything was simplified out. And notice if I set that denominator equal to 0, I will find out that 4 is excluded, negative 2 is excluded, and 5 is excluded. So there's the answers. There are the answers to this problem. Let's try another one. All right. So factor, 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 right? So I'm going to recognize this as a difference of perfect square. All right, let's see what we got down here. I believe this is x minus 8, x plus 3. All right, in this numerator, my common monomial term is 2x, and then I end up with x minus 9, I believe. So let me rewrite what I have in factored form. Give yourself room here, people, so you don't mess things up, because it gets squished and you don't know what you have. All right, so here's where I say, what do I have that can be simplified? And when I say simplified, it has to be the same thing in the numerator and the denominator. So there's one, there's another one. So what's left is x minus 3 in the numerator, 2x, x minus 9 in the denominator. There's the result of my multiplication. But we need to go back to the original denominator before simplification to see what's excluded. So if I set that denominator equal to 0 and set each factor equal to 0, I find out that my excluded values are 8, negative 3, 0, and 9. Okay? The last thing we need to cover today is, what do we do when we're dividing? Well, remember, when we're dividing fractions, we're really not dividing fraction. If I had 1/4 divided by 2/3, instead, how do I do that problem? I take the 1/4 and I multiply by the reciprocal. Hello. In this video, I'm going to do a sampling of problems from the review for the Chapter 10 and 13 test that's going to happen this Friday. February 14th. Happy Valentine's Day. So the first one I'm going to do here is number 2, which is that problem right there. And this says, notice the word simple interest. So the simple interest equation, which you'll be given, looks like that. So I recognize that I have an interest rate of 5%. I have a starting balance. That's my principal, isn't it? I have time of 10 years. What is the new total balance if I use simple interest? So I'm going to plug in what I know. P, we said, was 472. 1 plus my interest is 5%, and I'm going to do it for 10 years. So if I put that into my calculator, let's see if it makes sense. I should have something like 768.84. So round to the nearest cent unless you're told otherwise. Does that make sense? Yeah, we went from 472 to 768. 10 years, okay. Just looking at my equation, it looks good. Now that's the total balance. If they asked you how much interest was accrued, that's the first question, right? We take that 768.84 and we subtract off that original principal amount, and that means we earn $296.84 in interest. Right? Make sure when you're doing your test that you answer all the questions that were asked. There were 2 questions here, weren't there? Okay, that's number 2. I'm going to move to the next slide, and I'm going to do number 3. So it says, if you start a bank account with $10,000, P, and your bank compounds the interest quarterly, N equals 4, at an interest rate of 8%, how much money do you have at the year's end? Well, that means T equals 1, right? So this is the equation we will use is the compound more than one time a year problem. You will be given this equation, but it looks like this. So let's substitute in what we know. We're starting with 10,000. 1 plus our rate, which is 0.08, over 4, because we're compounding quarterly, to the 4 times 1, because we're talking about 1 year. So I'm going to plug that into my equation, into my calculator. Excuse me. I'm going to do that. I'm going to raise it to the 4. I'm going to multiply by 10,000. And I should have the total amount in my account, right, is going to be this much, round to the nearest cent. And the interest I will have built, right, I just subtract off that 10,000, I will have earned $824.32 in interest. Not hard, guys. You just have to recognize which equation to use and make sure you're plugging it into your calculator properly. All right, now we're going to do number 4. So it says you win the lottery and you get $1 million. And we need to decide between 2 plans here, right, to see which we want to use. So 5 years from now, so T equals 5. The first plan gives you a 6% interest rate and compounds the interest each month. N equals 12. 12 times a year, right? Plan 2 gives you a 6.5 interest rate and compounds the interest every 12 months. That means once a year, doesn't it? So plan 1 is a compound interest problem, so it's going to be, the amount's going to be 1 million, right? Times 1 plus the rate of 0.6. You're compounding it 12 times. Whoops, sorry about that. 12 times, and we're going to do it 5 years times the 12 times. That's plan 1. Plan 2 is really simple interest, isn't it? So it's A equals $1 million. 1 plus 0.065 raised to the 5 years. So let's see what numbers we come up with. All right, 1 plus. Right, so I'm raising this to the 60 because it's 12 times 5. Going to multiply it by the million. I have 1,348,850.15. All right, now let's do the other. 1.065, which I'm raising to the 5. Notice I make more money in plan 2. Right? Which plan do I want to use? I want to use plan 2. All right, again, plan 1, we compounded more than 1 time per year, so we had to use that equation. Plan 2, compounding every 12 months, is compounding once a year, which means I can use the nice simple interest equation. All right, moving on. Number 7 says you invest, don't worry about the end of, we're going to say you invest $100 each month for 5 years. All right, now we're talking about an annuity, aren't we? So we have a different equation for that. So that means our deposit is $100 every month, which means I deposit 12 times a year. My T equals 5 and my rate is 0.06. So the future value looks like this. The deposit, 1 plus 0.06 over 12 raised to the n times t minus 1 over. You have to be really careful putting this in your calculator, okay? Where you need parentheses is very important. So you have earned the future value of the annuity is 6977.00. How much did you invest? Well, I put in $100, 12 months. That gives me how much I put in per year times the 5 years. So I put in $6,000. How much interest did you earn? Well, the value of my annuity minus my investment means I earned $977. Okay. We're looking at number 9. You buy $18.25 worth of food at a restaurant. So the sales tax is 5.75% and you wish to tip. So notice that you only tip on the bill, not the tax. So I'm going to come down here and I'm going to say the tip is going to be calculated as 15% times that $18.25, right? Which I'll fill in a second. The sales tax is on the total amount of the bill there. So the tax is going to be 0.0575 times the bill, which I'm going to fill in there, and then we'll add it all up. So if I take 15% of 1825, I'm going to round to the nearest penny, and then if I take 0.0575 times 18.25, I get 1.05 as my tax, round to the nearest penny, and then I'm going to add it up. So I should have my total bill, including tip and tax, is $22.04. Okay, might run out of time here, folks. If I sell something for $2,200 but I get 15% off, I'm going to subtract that, okay, $2,200 minus 15% of $2,200. Here's my bill. Now I multiply, I get the tax here, so I'm going to multiply by 0.07. So 1870, $130.90 gives me the total. I think it looks like that, but I just did it quick. 1870 plus 130.9. Yep, there's my total.